Good day, grade 10. So we're busy with the algebra equations and inequalities and functions. I'm going to look at number 1.1. I am going to show you, but the expectation is not for you to know how to do number 1.1.2 because we haven't done exponents yet. Alright, but you can use your laws of grade 9 and try to solve that. And also at number 1.3, your laws of fractions that you took down, you can apply them. Alright, so number 1.1, what I am going to do, I'm going to see what happens here. Okay, so this is going to be, what I first need to do, I need to expand, and I'm going to expand this with this, and then this with this with this, and then this with this. Alright, so I'm going to say 3x times with x is equal to 3x to the power of 3, and then it's going to be 3x times with the 1 is plus 3x, and then negative 2x to the power of 2 minus 2 times 1 is equal to 2. Okay. Is there any like terms there? No like terms. Alright, so all I have to do now is I have to rewrite this as in descending powers. So it will be, oh, the negative 2. Alright. I forgot that negative 2 there. Thank you. Alright, so there is a negative 2 outside of the bracket, and then we simplify. Now I have my like terms. Okay, thank you. Sorry, we do apologize, Mr. Armstrong. Alright, so that means it's 3x to the power of 3, and then negative 2x squared, descending powers of x, plus 3x minus 4. Okay. Unfortunately, it is our answer. Okay, so although we haven't done exponents, I'm going to look at this one quickly. So let's see. I want you to follow with me. So once I have this outside of my exponents, that is my exponent standing outside. So do you know the law of distribution? It's similar to expanding. So if there was a 3 outside here, I would have made that 3 applicable to this one as well as this one. Okay, so the law says if there is something outside, I need to multiply it with the one inside. Okay, so what we're going to do here is I'm going to say 2 to the power of 2. I'm going to multiply it with that is standing outside, so it's going to be 2x plus 1. Okay, and then I'm going to say 3 to the power of 1 times with x plus 1. Okay, over 2 to the power of 2x times 3 to the power of x. Now I'm quickly going to expand this numbers here. I'm going to expand this with this. Let me just use a different color there. This with this, and then this with this. Okay, so my answer is going to look like this. So it's going to be 2x plus 2, and then times with 3x plus 1, and then 2 to the power of x times 3 to the power of x. What can I do? What can I do when my bases are the same and I'm doing division? What can I do? I can subtract the exponents. Okay, so this is a little introduction to the next topic, namely exponents. So that means 2 to the power of 2x plus 2 minus 2x. Okay, so that 2 is not going to be underneath anymore. And then I'm going to say times with 3x plus x plus 1 plus or minus? Minus. So we subtract that x Okay, and now we simplify. Now the same as I did with our normal simplification, I'm going to apply my rules there. This like terms there. Gelyksoortige terme, dit is dieselfde. Hierdie is ook dieselfde. So I'm basically left with 2 to the power of 2 and 3 to the power of 1. So if I simplify, 4 times 3 is equal to 12. Three to the power of 1. Alright, 3 to the power of 1. What is 3 to the power of 1? 3. It's just 3. Ek herhaal die vraag, wat moet by x kwadraat minus x plus 4 gevoer word om x plus 2 tussen hakie gekwadreer te kry? Right, in English, what must be added to x squared minus x plus 4 to make it equal to x plus 2 in brackets squared? Alright, now we're going to do a quick comparison. This is important. And so we are given x squared minus x plus 4. And then the other one that is given to us is this one of x plus 2 to the power of 2. Now what I can do, I'm actually, if I know this answer, I can go straight to the answer. So it will be x to the power of 2 plus 4x plus 4. Okay? So they ask us now, how do we make this thing? Yes, do you see that? Alright, so they ask us, how do we make these two things, I need to make them the same. Okay, so then what we're going to do, I'm going to do subtraction. So I can say, I'm going to subtract here. So that cancels out. Alright, so I'm left with the 0 here. And then that cancels out. So I'm left with so the problem is right here. So I'm going to say negative x plus 4x is equal to 3x. No? Negative x plus 4x is 3x. Negative 4x plus 3x? Alright, listen here. Alright, we are doing division. Not division, sorry, subtraction. We are doing subtraction. So how did I get to negative? How did I get a 0 here? And how do I get a 0 here? I say 4 plus 4 minus 4. Okay? Here I said x squared minus x squared. So this would be negative x minus positive 4x. And then my answer is going to be minus 5x. So my answer here is actually just, but we add 5x. So what is the question? What must be added to this? So 5x needs to be added to make it equal to that one.
Must we write that like when we have two? Must we write that?
Alright, so it is given that 2000 is equal to 2 times m to the power of 3 times n to the power of 3, where m and n are whole numbers, and then we should simplify this. At question number 1.4, they ask us to determine the value of m and m. How do we do this? We say 2000 is equal to 2 times m to the power of 3, n to the power of 3. I'm first going to get rid of the coefficient on the left hand side. So I'm going to divide both sides by 2, and then on the left hand side is going to be 1000 is equal to m to the power of 3 n to the power of 3. Okay, how do I get rid of that powers there? I divide on both sides. Okay, so that means I get 1,000 there. That 2 cancels out on the right hand side. Now I want to get rid of what is bothering me now. That 3 and that 3 there. Exponents. What can I do? Cube root. So I'm going to say it's cube root of 1,000 is equal to cube root of m to the power of 3 n to the power of 3. So what am I left here with on the right hand side? M n and 10. That's how we do that. Right, that is number 1.4. Quickly do number 1.5.1 and 1.5.2 on your own, and then I'll be looking at it in a sec. Alright, 1.5, here should be a plus sign there. Okay, so what am I doing? I'm checking the factors of my first term and then the factors of my last term, and then I'm going to cross multiply that. Alright, so what is my factors of 3x? It's 3x squared and x. The product of this is going to give me to 3x squared. Okay, so that's my factors of my first term, and then factors of my last term is going to be 1 and 2. Okay, so I could have written 2 and 1, but just check here if I write down 2 and 1, what happens? If I write down 2 here and 1 there, is it still going to work? Alright, so that's 2. Then it's going to be 2 times, then it's going to be 2x and 3x, and then it's going to be 5x, but that should be a negative and that should be a negative. So that means I have a negative here and a negative here as well. So my answer, now I use this, it's 3x minus 2 and then x plus 1. Yours also works. It also works. Alright, next one, question number, what do you think we're going to do here? Grouping, okay. What can I take out between the first two? The n. If I take out the n, it becomes n plus 3. What can I take out with the negative 5? And then it becomes n. Okay, so it becomes, because a negative divided by a negative is equal to a positive. So if I multiply this 5 times with 15, I'm supposed to get a positive, a negative 15 still. If there was a negative and I multiplied this, if we say, for example, that was 5 times with negative 3, then it would have been positive 15, and that's not a positive 15. Okay, so now it's fairly simple from this. Now I can just write down n plus 3 and then n minus 5. Question number 1.6, vraag nummer 1.6, skryf neer minstens 3 rasionale getalle tussen vierkantswortel 2 en vierkantswortel 10. Alright, so I'm going to write out my numbers quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so there's square root 2 and there's square root 10, and then they ask for rational numbers. So it will be 3. I only see 2. So it's 4 because that is 2, and then it's 2 and 3.